This is the Unit 9, 7H End of Unit Assessment Test Correction video. Question number 1. Lynn is about to roll a standard number cube. Describe an event that is likely to happen, but not certain, on the next roll. Describe an event that is unlikely to happen, but not impossible, on the next roll. Describe an event that is certain to happen on the next roll. So when we started probability, you remember that we had a number line, and it had 0, and then 1, and then 50%, and 75%, and then 25%. And so we called this one impossible, this one was certain, this one was as likely as not, this one was unlikely, and this one was likely. So if we think about a standard number cube, the sample space for a standard number cube is 1, 2, 3, 4, 5, 6. So if something's likely to happen, it needs to be here, which is about 3/4. So if I look at this, or more, so if I look at this, I'm going to say maybe likely to happen, I would roll number 1 through 5, or 1 through 4. If it's unlikely to happen, I'd roll like a 1 or a 2. Certain to happen, just a number. Okay? These are just examples. It could have been a bunch of different things. Elena would like to know the average height of a 7th grader in her school district. So this is 7th graders in her district. She measures the heights of everyone in a sample of 20 students. The mean height of her sample is 61 inches, that's the mean height, and the mean absolute deviation is 2 inches. So remember that this is the distance from the mean. So if her mean is 61, we're going to think about maybe in this sample, most of the people fell in this range. Okay? So it says the mean height of these students is likely to be the same as the mean height of 20 more random students. No, because it's a sample, so that's absolutely no. Another random sample of students is likely to have a mean between 57 and 65. So this was just 20 kids, and it's between 59 and 63, so this is possible. Elena would be more likely to get an accurate estimate of the mean height of the population by sampling 40 people instead of 20. Absolutely. The more people we have, the closer we're going to get to what the actual mean is. The median height of the sample must be between 59 and 63. Must be? No. The mean height of these 20 students is likely to be the same as the mean height of all the students in the district? No. So the correct answers were these two. Question number 3. It says, below is a dot plot showing how much time customers spend in a store rounded to the nearest 5 minutes. So it says, which of these is a representative sample of this population? We want our sample to have the same center, shape, and spread as the actual population. So if I look at my population, it goes from 5 to 40. So this one goes from 5 to 40. This one does not, so that's a no. This one goes from 5 to 45. This one goes from 5 to 40, so this is a no. The center of my data looks like it's about 23, so yeah. And then the same shape. So I noticed that on the original population, it's got a lot of people who are at 5, and then a bunch at 25 and 30. This has a bunch at 25 and 30, but not a lot, so the correct answer was D. And remember that these were out of order, so you needed to make sure that you chose D. Diego predicts that his basketball team has a 2/3 probability of winning each of their next 7 games. Okay? Select all the ways Diego could accurately simulate the number of games his team will win. Diego will make a spinner with 12 equally sized sections and win on 4 of them and spin it 7 times and see how many it ends on wins. So if I do a 4 out of 12, that's 1/3, so that's no. Roll a standard number cube 7 times and count the number of 2s. So remember that the sample space for a number cube is 1, 2, 3, 4, 5, 6. Counting the 2s, no, that's a 1/6. Put the numbers 1 through 7 in a bag and pick a number from the bag. So that's 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, That's actually 8 numbers, so that doesn't work. Roll a standard number cube 7 times and count the number of 1s, 2s, 3s, and 4s. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah, that's 4, 6, or 2/3. That one works. Put 10 white chips and 5 red chips in a bag. Pull a chip from the bag, record its result, put it back in the bag, do this 7 times, and count the number of white chips drawn. So we've got 15 chips, and 10 of them are white, so that's 2/3. Yes, that would work. So those two would both work. Next one. 2 classes of students took an exam, and Andre found the list of 11 scores in Class A. So he made a box plot. All right, so if I look at my numbers, they are in order. My minimum is 65. My maximum is 100. So my minimum is 65, and my maximum is 100. Okay. My median, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, is going to be the 6th number. 1, 2, 3, 4, 5, 6. All right, so my median is 85. My lower median is 70, and my upper median is 90. So my median is 85. My lower median is 70 and 90. Okay, so here's my box plot. Okay, all right, so now I've got my 2 box plots. Which class had better overall results on the exam? Well, it's going to be Class A, because Class A, the lowest kids scored was 65, the highest was 100, and their median is way over here at 85, so it's A. Which class had greater variability in their results? Well, this class went from 60 to 90, which is 30, and this class goes from 65 to 100, which is 35. So it is also going to be A. All right, a store owner asked each student to write yes or no on a piece of paper as they leave, secretly writing down whether they were happy with their experience. At the end of the day, the owner selects 12 slips at random and look at them, and these are the results. Estimate the proportion of all shoppers who were happy with their experience that day. So 1, 2, 3, 4, 5, 6, 7, 8 out of 12, which is 2/3, so something like that. The store owner asked each person to write yes or no on a slip of paper, secretly writing down whether they were happy. All right, and so they found 25% of the people marked yes. Should the store owner believe that these 2 results are reasonably represent the overall population of happy shoppers, or should they gather more data? Okay, so the store owner should gather more data. All right, next one. The store owner asks each person to write yes or no on a slip of paper as they leave, secretly writing down. At the end of the day, he selects 12 at random. These were the results. On a different day, the owner found 25% of the selected students were marked yes. The store owner believes that these 2 results could reasonably represent the overall populations, or should he gather more data? And so this is the same question as here. And so you should have written something like, the store owner needs to gather more data because the first day 66% were happy. Day 2, 25% were happy. And it was only 24 samples. So it's not enough samples. He needs to gather more data. All right, next one. A standardized test has 4 forms, and each form comes in 5 colors. Assume there are an equal number of each test. How many tests can be made? Well, I'm going to use the fundamental counting principle and just multiply, so it's 20. What is the probability that Lynn receives a blue A? It's going to be 1 out of 20. What is the probability that Manuel receives a yellow or a green? So there are 5 kinds, so 2 out of 5 would be the answer for this. Okay? Or if I did it using my sample space, it would have been 8 out of 20, which is also 2 times. All right, here we go. Paul has a spinner with 4 colors. He spins the spinner 60 times and records what it stops on. The results are in the table. Paul will spin the spinner additional 450 times. How many times should he expect the spinner to stop on blue? So his probability was, or his proportion was 14 out of 60. So he had 14 out of 60 on his experiments, and then we've got 450 times. And so if you were to figure this out, you would find that he should choose 105. All right, a couple more. Suppose there are 360 kids in the 7th grade in a middle school. The table shows favorite outdoor activities for a random group of 7th graders from the school, indoor activities. All right, so phone time. So 20 out of, how many kids did they do? So this is 24 plus 24. So it's 20 out of 48 chose phone times. And then if we go out of 360 and we do the math, we would find that 120 kids would choose phone time. All right, next one. State representative took several random samples of adults to find out which place they visit most frequently. The average of all the surveys is shown in the table. Based on the table, what conclusion can be made? So we've got 25, 30, 40, 50, 60, 70. So we've got 70 people, and it says the aquariums. The aquarium is 8 out of 70. Then we have 17% of the people visited the park, so it's 17 out of 70. Then we've got 50% of the people went to the zoo, so that's 31 out of 70. And on average, 2 out of 10 visited the museum, 14 out of 70. That's our answer right there. Okay, next one. Nicole wants to conduct a survey of opinions of 7th grade students in her middle school. Which sample would give her the most accurate results? So she wants 7th grade students at her middle school. Random students during a football game. These might not be 7th graders. Students during science class. This is not going to give all the students. Teachers, no, because teachers don't count. They're not kids. And then random students of 7th grade people during lunch, that's the one we want. All right, next one. The table shows the number of points 2 teams scored in 5 games. So I found the mean, which was 22. And then I found the mean absolute deviation, which was 4. And then I found the mean, which was 22.6, and the mean absolute deviation, which was 5.04. And then the difference between them was going to be 1.04, but rounding to the nearest integer would be 1. All right. Test scores in Mr. Miller's math class. What was the range? So the range is the difference between the lowest and the highest number. If I subtract them, I get 42. And finally, the probability that a person in a certain town has brown eyes is 2 out of 5. In a survey of 450 people, how many people would you expect to have brown eyes? So I'm going to multiply by 90, 180 people. Thanks for your attention.